The other thing that we need from algebra, which we're going to use right away, is factoring. Not everybody's favorite topic, but we're going to narrow it down to just a few types of factoring. So the first type that we'll need is a greatest common factor. This works for all problems. Whether you have 2 terms or 20 terms, you can always try greatest common factoring. And you'll see some of these depend upon how many terms you have, whether it's 2 or 3. But this one you can use on all problems that you're going to see in this class. Works for all problems. You may not be able to pull one out, but you can always try. So I say works for all problems, it means you can try it for all problems. Some of these you can't try if there are a different amount of terms. So the greatest common factor, you don't necessarily get a definition in high school, and I think it actually helps to know the definition. So I'm going to actually give the definition of this one. It's the biggest number and least power of x. That can go into everything. It's the biggest number and least power of x that can go in to all the terms. So let's look at this first example. We have 4x cubed minus 6x squared plus 8x. So first of all, what's the biggest number that goes into 4, -6, and 8? Well, 4 goes into 4 and 8, but it doesn't go into 6. So let's go with 2. 2 goes into 4, 6, and 8 because they're all even numbers. So I'm going to pull out a 2. There's my biggest number that goes into all the terms. And what's the least power of x that we have here? We have x to the 3, x to the 2, and then just a regular x, which means x to the first. So my least power of x is just a regular x. So we figure out the biggest number that goes in all of them, the least power of x, and then we distribute back. So 2x times what is going to give me 4x? So first of all, the numbers. 2 times what is 4? 2 times 2 is 4. And then remember, when you multiply bases, you add powers. So this is x to the first, and I need to multiply it by x to the 2 to get to x to the 3. Right? Because we want x to the 3, x to the 1, plus 2 is going to give me x to the 3. Remember, multiplying bases means add exponents. Next piece, 2 to get to -6, we'd multiply by -3. And I want to get from x to x to the 2, so I need to multiply by an x. X to the 1 plus x to the 1 is going to give me x to the 2. And last piece, 2 times 4 will give me 8. So I need to multiply by 4. And then we have x to the first to be x to the first, which means we don't need to multiply by an x. We don't need to raise the power at all. So let's double check that. 2 times 2x squared is going to give me 4x to the third. 2x times -3x is going to be -6x squared. And then 2x times 4 is going to give me 8x. Okay, so there's the greatest common factor. We can try that for all problems that we see. The next type of factoring that we'll use in this class is called the difference of squares. So this we would only try if we have a binomial. Bi means 2, something with 2 terms. If it has 3 terms, I wouldn't even bother trying because it only works for something with 2 terms. Binomial, 2 terms. So one thing that we want to know, it's a difference. Difference means subtraction. If it was a sum, that would mean addition, but it's a difference. So it's going to be subtraction. And we need it to be of the form x squared minus a squared. So as long as we have something squared in our first term, so in this case x is squared to be x squared, kind of weird with just letters, minus another thing that's squared, we have a getting squared. As long as your first term is squared, you have a difference, which is subtraction, and your second term is squared. How it will factor is it'll be x plus a times x minus a. A little trick that works as long as you have a difference of 2 square numbers. So let's try that with a little bit more concrete example. If we have x squared minus 81. So I have a difference and I have binomial. I have 2 terms and it's a difference. So let's see if it's a difference of 2 squares. Let's think of what would be squared to be x squared. Kind of a weird thing because it's a letter or a variable. Well, x would be squared to be x squared. Minus, what squares to be 81? 9. So we have x squared minus 81, which is really minus a 9 squared. So when we factor this, it'll work to be x plus 9 times x minus 9. Okay, there's our binomial method, difference of two squares. We could always try a greatest common factor on a binomial, something with two terms, because it works for any terms to try. But if it's a difference of two squares, this will be our method. Our last method that we really need to know in this class is reverse foiling. And this is specific to trinomials. Tri means three terms. A trinomial, something with three terms. So we don't really need a formal definition of this. We have something like x squared plus ax plus b. We have an x squared and an x term and then a constant at the end. So let's think of, we probably did this in high school. Does anybody remember what you have to do to be b? Is that the one you multiply to be or add to be? You multiply to be the last term. So in this case, it's called b. So we're going to multiply to be that last term, which is called b in this one. And then we add to be the middle term. And add to be, and the middle term of this one is called a. So let's try that on this one. So we want to multiply to be the last term. So we're going to multiply to be negative 15 in this one. And we want to add to be the middle term. We're going to add up to be negative 2. So we're going to write our parentheses for some reverse foiling. We have x and x to multiply to be x squared. And we want to multiply to be a negative 15. Well, in order to multiply to be a negative, what do you need? A positive times a positive, a negative times a negative, or a positive times a negative? To be multiplying to be a negative, you need a positive times a negative. So I'm going to put those in there. And I want to add up to be a negative 2, which tells me the bigger factor is the negative one, because when they add up, you get a negative number. So some factors of 15 and 1. So remember, the bigger one has to be negative because we're adding up to be a negative. So if I put a 15 here, it'd be a negative 15 plus 1 would give me a negative 14. That doesn't work. So other factors of 15 would be 5 and 3. And again, because we're adding up to be a negative, I want the bigger number to be negative. So if I had a negative 5 plus 3, that would give me negative 2. So negative 5 plus 3 adds up to be negative 2 and multiplies to be negative 15. So you run through the factors of the last term, and then you see that it equals the middle term when you add them. So 3 minus 5, or 3 plus a negative 5, is going to give me that negative 2 in the middle. So there's our factoring. On the next page, we have examples of how to do them. I would suggest that you try to do the ones that you can and then go back and watch the video. And it's totally okay if you don't think you're great at factoring yet. We only use it a little bit in this class, and you'll get better as you go.